We have come far away from the traditional software deployment methods, where you used to take software and used to deploy in singular servers using singular virtual environments. Nowadays, the whole system has progressed into something else, where you take containers and deploy your software in multiple containers, implementing a microservices type of architecture. So for this purpose, we use tools like Docker, LXD, and Rocket. But for maintaining and managing these containers, you need to use orchestration tools. And that's where tools like Docker Swarm, Kubernetes come in, or ECS or EKS, cloud services. So in today's tutorial, we'll be discussing Kubernetes because it is one of the best known tools for this purpose, and it is the industry standard for orchestration of containers. And again, guys, Great Learning Academy. It's a free initiative by Great Learning where you can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. And if you haven't subscribed to our channel yet, I want to request you to hit that subscribe button and turn on the notifications bell so that you don't miss out on any new updates or videos released from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any queries or suggestions, and I will respond to your comments. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out on any new updates or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. And make sure to comment on the video for any queries or suggestions, and I will respond to them. Kubernetes tutorial. So guys, now we'll be learning about Kubernetes and what it really does. Now to give you guys a very small brief, Kubernetes is a container orchestration tool that helps us in software development in various different stages. So that was a brief, and we will dive deeper into understanding what Kubernetes is over the course of this tutorial, so that you guys get a very good idea about what it really is and how it will really help us out in software development process, right? So let us begin by going through the agenda and seeing what all the different topics we'll be covering in this particular tutorial. So let me bring it up. So the first thing we'll be, going through is why do we use Kubernetes? Now, Kubernetes is a part of software development process, but where is it really used? And to understand that, we have to understand about containers also. So we'll be talking about what are containers, and we'll be talking about why do we need containers? How does Docker create containers? So you'll be learning a few extra things with Kubernetes because they are somewhat of prerequisites. You need to understand what containerization is and what do containers do or play, what kind of role do they play with Kubernetes, and how does Docker help in all of that. And then we'll be learning what is Kubernetes properly, going to detailed overview of what Kubernetes is, its components, its architecture, etc., etc. And we'll also be understanding how does Kubernetes function. We'll be learning how to install and set up Kubernetes on our own in a Linux instance, and we'll be learning what YAML files are, how do they help us in configuring Kubernetes. And finally, we'll have a demo so that you guys get a practical understanding of what Kubernetes is and how it really helps us to make software development a better process. So this was the agenda. Let us continue and start talking about the first thing we wanted to discuss, that is, why do we use Kubernetes? All right, so this is a very fundamental question. Why do we use Kubernetes at all? Now, to understand this, we have to understand software development. So I'm gonna bring you guys through a software development pipeline. So what is a software development pipeline at all? So take an example about car construction or automobile construction, and you would remember whenever you saw ads as a kid, or if you saw Discovery Channel as a kid, you'd see that there was a whole
production line over which multiple car chassis would be, going over, and there would be robots on each side coming in, welding in something or attaching a certain part, and doing a lot of different various alterations on the chassis until in the end you got the perfect car. So similarly, even in software development, you have a similar production line, but instead of a production line, you would call it a pipeline. And in this pipeline, you have different people playing different roles. You have the developers creating the code. You have the testers testing the code. You have the operations team making sure that the software is deployed to the end users. So you have a lot of different people playing different roles. So in a software development pipeline, you're basically they're showing the process of creating the software from the start of its life cycle to the end of its life cycle, right? So this is what a software delivery pipeline is. It allows you to deliver software to the end user. So let us look at a very standard software delivery pipeline, because that will help us know everything in a much more fundamental way without confusing us with any unnecessary intricacies or complications. So let us look at this. A standard delivery pipeline. So first we have a developer. Now the developer's role, as I stated earlier, is to create code. So he would basically sit down, write his code in his integrated development environment, making sure that every part of it runs. If there are any errors, he will try to resolve those errors, whether it is in the code or in the compiler, whether he needs another plugin for it, or whether it's something in his computer's environment that he needs to change. Basically, he will do everything there is to make sure that the code is running on his system. Now, once the code is there, so that code will basically go to the next part of the pipeline. That is the building process. Now, in the building process, what really happens is your code becomes the software. So you have to understand that your code is not the software by itself. Your code is just a written set of instructions that will tell the machine to do a specific task. If you've written print hello world, you're telling the machine that you want to print the particular statement hello world. It is not a software that prints hello world. To make it into a software, you need certain dependencies. So those dependencies can be anything. They can be the extra libraries that you need to execute your code. They can be extra functions, the external functions that play a big part, or they can be particular tools or database, or it can be the environment. It can be any sort of thing. It can be a framework also. So all these dependencies are the things that basically make your code a software. So you take those dependencies and you take this code and you put it into a single executable file. You can call it an executable, you can call it a build file, you can call it a package, you can call it anything. But basically it is the software. Now, in the process where you are taking and combining the code and the dependencies together into one single package, that process is called the building process. Now that also happens on a particular machine, on infrastructure, because it also needs a place to happen, and using a certain build tool, whatever code you're using based on that. So this is again also a part of your software development pipeline, where the code becomes the software. Now you have the software in your hand. It is the software that you can use for giving it to your end users. But that's not what you do. You don't directly give it to the end user. You have another player over here, that is the tester. Now the tester is responsible for testing the software dynamically. He makes sure that this particular software has all of those different parts that were decided in the planning phase. When you're developing software, you have a lot of different phases, and planning phase is one of the most important phase, where you basically look at the stakeholders requirements. If the stakeholder wants you to have a payment feature, you'll need to have a payment feature in your software. So those requirements will be tested by the tester in acceptance testings, and then he'll do a lot of different types of testing, making sure that the product or the software or the product is very secure, very robust. It doesn't break down easily with various different inputs into its input places, right? Or it is very put together very well. It's strong, and unit testing is going well, and then the integration testing is going well, and then he would also check it for he would test every small thing, so the test coverage for every part of the software is also high. So this is what the tester will do. He will test the particular software rigorously so that it is very polished. If he sees that there are some issues, there are some mistakes, then he would inform the developer on the same. So the developer will look at the list of things he needs to make a change on, he would make the change on them, and then he will, send the code for building again. So the code will again be taken with its dependencies and put together and become a software in the building process, and then it will go again to the tester, and the tester will this time again look at this particular software, and he will test it again rigorously for all the different things that we just talked about, and then he will decide again whether to send it back to the developer with all the mistakes if there are any new, or if he thinks it's totally fine, then he will send it for the deployment. That is the last part of your software delivery. So here you're basically delivering the software. That is the delivery part of the software, where you're giving it to the end users, or you're giving it to the stakeholders, or whoever is the basically end user of it, right? If it's you and I, maybe if both of us are using YouTube is a software and it is delivered to the end users, right? So it is in a production environment. A production environment is basically a place where you have the final version of a software after it's gone through multiple iterations of changes over time. So this is the deployment process, and this is basically your software delivery pipeline. The developer writes the code, then the codes become into the software in the building process, and the tester tests the code, and then it goes for the deployment. So this is very standard and simple delivery pipeline. In companies, this can be very different. It can be a lot more complicated, and it can have a lot of different parts also, but you just need to understand this as a simple one. Now that you know this, you have to understand that there can be issues over here. Now, I am going to point out one issue, and I'm going to tell you what helps resolve that issue. So, if you look at the issues we used to face before containerization was a thing. So, when we talked about the software delivery pipeline, we did not talk about containerization, and we assumed containerization was not a thing when that software delivery pipeline was in place. Now, what kind of issues can happen in this particular pipeline that we just discussed? So, the issue that can happen is a big one. It is the bottlenecking issue. So let's see how that happens. So let's say that the developer is there, right? He writes the code, he makes sure that the code is working well. So to make sure the code is working well, he does a lot of changes on his system, because his code might not be working with a certain version of the tool he's using. Let's say he's using PyTest 5.3.0 and it's not working with it because he needs the newer version to implement that new thing he wanted to implement. So he uses PyTest 5.4.3 and it starts working. And not just that, he makes changes in the environment to suit the code. He changes, he adds new plugins and he uses a different kind of set of tools also for that. So here he makes sure in every way that his code is running fine. He says that this code runs fine on my computer. And once he's done doing that, he sends it to the next part of the process, that is the building process, and then it comes to the tester. And when the tester is basically trying to run the same particular code on his system, he sees that it's not running. He says that this code does not run on my system. Now, the issue here is that the developer was not able to communicate properly all of the changes he made. So maybe he was able to tell what kind of PyTest he was using, or maybe he didn't even tell that, and he was not able to communicate the environment changes, the plugins he used, or the tools he used. So the tester is not aware of them, and on his system, he has totally a different environment that does not suit the code that has been written on the developer's environment. So this way, this code does not run. And this is not a outlier. This can happen a lot of times. You yourself may have seen this kind of scenario appearing up when you're running a code on your system versus when you're running a code on your friend's system. It can react different, it can behave differently to different environments. So it is key to have consistent environment. Now there are two solutions to this. One is that the developer and tester have rigorous communication on every small aspect of this code, which is something that is possible, but it is very tedious to do so, because when you have a very large company and a large number of people working in it, it's difficult to track all of these small changes. Or even in a smaller company it would be difficult. It's not to say that even a small company can't do that. So to resolve this kind of bottlenecking issues where the environments are totally different, where if you look at the environments again, where you have the developer having CentOS operating system, having PyTest 5.4.3 and PyCharm integrated development environment, and he's working with Django backend code and certain dependencies, and the tester is working on the same Django backend code and certain dependencies, but he has CentOS operating system and he has an older version of PyTest and a different IDE. So even these kind of things can make change. can make a big change. You can have PyTest in this particular IDE, and if you have PyTest of older version on this IDE, then your code may not run. A good example is Java 8 and Java 11. The particular compatibility between the two is totally different. It's not very easy to convert the code from one to the other. That is just an example, right? So this is a bottlenecking issue, and we can resolve that issue using another method called containerization. Now let's see what happens when we introduce containers or containerization. Okay, now to explain what containers are. So imagine containers as private boxes in which you keep all the things that you want to keep in. So in containers, basically you will be placing a virtual environment. You'll be you'll be putting all the tools, you'll be putting your code, you'll be putting your dependencies inside of this particular box or this container, and then you'll be shipping this container like how you ship normal containers in real life. So this container will not be interacting a lot with the outside environment. So it will remain consistent. So if you ship this container itself, then all the changes that you made inside of this container will also be transferred because you're transferring the container itself. It's like taking your laptop and giving it to the tester, which is not possible when you're developing software, right? So instead of giving the laptop itself, you just take a container and you put a virtual environment inside of it, and you basically put all the code, all the dependencies, and all the tools you need to run the code, to execute the code, to test the code, and deploy the code, all of it inside one container, and you transfer or ship the container itself without actually giving the code directly. So in the same standard delivery pipeline, if we introduce containers, it would look something like this, where you have containers doing a lot of the handiwork, where the developer takes the environment, and he takes the code, and he takes the dependencies, and he takes the tools, and he puts it inside of the container, and then he makes all the different tweakings. If he wants to go to the latest version of PyTest, he would do it inside of the container. At least he will make that change inside of the container. And once he's made all those changes inside of the container, he ships the container itself. So when the tester receives the container, he can execute the code inside of the container, right? And this way, there are no consistency issues. Why? Because earlier what we were doing we were doing it on individual laptops where the environment can vary very differently because standardization is difficult to implement. But inside of a container, that's not the same case because the container is basically the same environment being shipped. Instead of just giving the code, you're shipping the whole environment itself. And the tester will run the code inside of this environment where all the changes have been already been made by the developer. So this time the developer says that the code runs fine on my computer, and the tester also says the code runs fine on my computer. So this is basically what containers do. They help us resolve the problem of bottlenecking. And bottlenecking can be very difficult thing for a software delivery process, because if you have a bottleneck in some part of your software delivery pipeline, you're not able to deliver your software. And these days the market is very hungry and it needs software consistently and continuously. So imagine in your bathroom you have a tap, and that tap is not giving you water because there is a blockage somewhere, there's a bottleneck somewhere where the water is stopped. So you're not able to use water for yourself, right? And water is very important for us. Similarly, even in software delivery pipeline, a bottleneck can be very harmful. So that's why we use containers these days. Now there are more reasons behind it, which we will discuss just in a minute. So I hope you guys understood what the issues were before containerization was a thing and what happened after we introduced containers. All right, so what is a container? Let's dive a little bit more deeper into what a container is. So containers are software. They are a software. They're not a physical thing. They are basically software that emulate a virtual environment, or you can have a virtual environment inside of it, that wrap up all the parts of a code that you've written and all of its dependencies into a single deployable unit that can be used on different systems and servers. So you're basically taking the code, the libraries, the operating system, and the environment as a whole together, and you're putting it inside of a container, and you're shipping this container to different systems and servers wherever your requirement is. So this way you're creating a consistent environment so that there are no, consistency issues. You can compare containers to virtual machines. Your containers are basically similar to virtual machines in the matter of fact that they emulate a certain environment. Virtual machines also do that. They basically are virtual machines. If you want to use Ubuntu, you can use it in a virtual machine, and if you want to use it in container, you can do so. But there is a difference. Even though containers are like virtual machines, they are not virtual machines. They behave similarly, but they are not the same thing if you go deeper dive into it, so containers have a lot of differences from virtual machines, where in containers, if you had to say, when you put an environment or an operating system within a container versus within a virtual machine, the difference is that containers are very lightweight, as in they don't have every part of an operating system. They only have the very core part of an operating system that is required to run certain processes. So in software development, on a server, you will not need a graphical user interface. Windows has a graphical user interface, but that's for us humans to use, right? For software to run, and if the only purpose is for the software to run, then you would not need a graphical user interface. So that is unnecessary. So on a container, you will not have ever a graphical user interface for any operating system. Whereas on a virtual machine, you will have that. You will have the whole operating system, not just the core parts of it. So this makes virtual machines a bit more heavier than containers, because containers only have the bare necessary parts, whereas VMs have everything. Now, when we talk about the architecture, we discuss how container acts like any other software within the host operating system. It has its own services and apps, but it shares the kernel with the host operating system. It gets the resources from the host operating system's kernel itself. Whereas a virtual machine is completely isolated. It has its own apps and services and its own kernel. Now, it uses something called a hypervisor, about which we don't have to go into detail, to obtain resources. And when we talk about isolation, definitely virtual machines have more isolation than containers, because virtual machines have that type of architecture itself. But containers have adequate isolation, and that is enough. And there are a few other differences between containers and virtual machines. One of them is scalability. As we had talked about it earlier, it's easier to scale, or it's easy to scale containers, because containers are very lightweight, because they only have the bare necessary parts. They don't have everything. And it is a little bit more difficult to do the same with virtual machines. You can do it, but it is a little bit more difficult to do so with virtual machines, right? So this is basic differences between containers and virtual machines. I hope you guys understood what they are. Now let's move a little further and discuss why do we need containers. As we discuss in detail about containers, we also need to know why we need these containers, right? What does it all relate to? So we already know one reason, and we have discussed that in extensive detail, that is consistent development environments. We need our environments in a software development process to be very, very clear and without any bottlenecks. And to do so, we make use of containers, and they help us to maintain a standard set of environments across different systems, and it makes it all much more easier. Now, there are other reasons to use containers also, and one of them is microservices. Now, some of you may already know this, and some of you may get it from the context over here. Microservices, what does the word itself mean? It means small services. So whenever you're deploying a software, you do not deploy a software in a single big file. You try to implement a microservice type of architecture, where you divide the whole software into distinct parts that are interconnected with each other, and these distinct parts play a certain role in the software. So let's say that there is a food delivery service, and in this food delivery service, you have multiple different things. You offer payments, you have delivery person tracking, you have grocery shopping, you have parcel delivery, and you have your restaurants reviews and everything. So you have like 5 different services over here that as a whole form the software, that is the app, right? That is on your mobile. So even though all of these things together form an app, they are not always implemented in a single file. You will have them divided into different parts. like 5 different parts. So that is the implementation of a microservices type of architecture. Now, what role does a container play over here? A container contains all these different 5 parts. Now, all these different 5 parts will be interconnected to each other, but then if you're using containers, then this makes it very easy. Now, why are we storing all these different parts in containers? Because it becomes very easy to manage them. It becomes very easy to maintain them. That's right. Like if you have different parts in different containers, then it becomes very easy to individually manage them. So let's say you have a payment feature and there is one team working on the payment feature, and on the rest of the services also you have different teams working on them. Now these different teams have different deadlines and different requirements to fulfill. So they all have to only work on the individual service that they're working on, right? They don't have to update the whole thing whenever they have to push an update. They only have to update the small part. So that makes it easy when you're managing all of it using containers. You just push, the new definition and the container goes up and, it's updated. And containers were very easy to manage compared to, just your normal software. And we have special tools for that purpose. They're called orchestration tools that help us to manage all of these different multiple containers. So it becomes very easy, and scaling also becomes easier. If you want to scale, you want to add more number of servers for some particular, service that you're offering, then it becomes easier to do so, right? That's why we implement microservices architecture, and that's why containers are used over here. If you're still a little bit confused about what it really does, do not worry, you will get the idea slowly as you learn more about Kubernetes, right? So over here we now get to the question, what does Kubernetes do over here? Because that is the main thing we want to study about, and we really haven't mentioned it a lot. Actually, we have talked about what is happening, and Kubernetes has a role in that. What is the role in Kubernetes over here? So Kubernetes is a tool that allows us to manage multiple containers at the same time. So if you have Kubernetes, you can manage multiple containers that have multiple different services within them very easily. So Kubernetes is an orchestration tool. It allows us to orchestrate all the different containers there are. Now, it is just like your music opera, right? Where you have one person, waving that stick. If you've seen cartoons, or if you've actually been to some of these music symphony places or an opera where you have one person. So they're called orchestrators, right? They orchestrate the music by the swish and swish of their wands, right? Similarly, even Kubernetes is orchestrating. It's managing all of these different multiple containers. It's making sure that they're always up, they're readily available, they're very safe, they're very secure, and that you can manage or monitor them, all those kind of different things. We will learn more about all the different features of Kubernetes in detail later, but for now, understand what the role it plays over here. So it basically manages its sole job is to manage the containers, right? So that's what Kubernetes does. Okay. So generally, when you are using a microservices architecture, you would implement it in the end of your software delivery pipeline where you're delivering the software part. So you are delivering the software. So in your production environment, you have all these different multiple containers containing different services, and to manage, monitor, and maintain them, you use Kubernetes, right? So I hope it's clear what does Kubernetes do over here. Right. So how do we create containers? We can create containers using different set of tools, or different tools, not set of tools. So what kind of tools can you use for this purpose? So there are many different tools that you can use. There is Docker, there is LXD, and there is Rocket. Now, these offer multiple different features within them, but the most popular one over here is Docker. And we will be studying Docker. Now, the reason behind why we'll be learning and using Docker instead of any other is because it has become very popular. It was started around 2013, 2014, where the company called Docker came up with this this container creation tool called Docker. And it was very helpful and people really liked it. Now, the idea of containerization is not something new, or is not something that Docker came up with. It has been there for some time. If you guys know about it, there used to be something called root containers. that were there in early 2000s, but they weren't really widespread and not used that much. Now, because of various different factors and because of how easy it is to use Docker, it has become an industry standard nowadays. Almost everyone who's implementing containers is using Docker containers, right? Because it is so easy to use Docker containers. All right, so that's why we will also be studying about Docker. So let us move on and discuss what is Docker. So Docker is a tool that helps in developing, building, deploying, executing software in isolation. And it does so by creating containers that completely wrap up a software. We've already know what containers are, and now we know what Docker is. Docker is a tool that allows us to create containers. So if you wanted to wrap up an application in different containers, you could do so with the help of Docker. Now, another thing about Docker is that it creates a layer of security over these containers. So the containers you create with Docker are a lot more secure and robust than any other, right? So now let us move on to discuss how does Docker create containers. So guys, I have to admit, I told you a lie. I told you that containers are the ones that are being shipped from one place to another in the software delivery pipeline, which is not entirely true. There is a certain perspective you have to take if you want that to be true. What really happens is that you're basically shipping the blueprint of that particular container. Now, what is a blueprint over here? So let's take an example. Let's say that you wanted to build a house. How would you go ahead building that house? Would you just take the cement and the bricks and then just start putting it together? I am 100% sure none of you can do it unless you are a civil architect. And if you are, what are you doing here? Well, anyways, so it is not easy to do so without having a plan in mind, right? You cannot go and build a house without having a full set of plan, deciding all the requirements you have, all the materials you need, all the resources you have, and all of those different things. And that's where a lot of times people use blueprints to decide how a house would look, what are the dimensions it will have, what is the materials it will use, and all of those things. A blueprint will help you plan it all out. Similarly, even within Docker containers, you cannot create containers directly or just think about containers and they'll just appear out of thin air like a snap. What you have to do is you have to take images. Now these images are basically blueprints. We call them basically images. Instead of calling them Docker blueprints, we call them Docker images. So Docker images are the ones that define the different set of configurations that will be there inside of your container. So let's say that there is a user and they want to create a container. So how will they do it? To do that, what they will do is they will take up a Docker image and they will reference it when they are creating a container using the Docker CLI, that is the command line interface. So they'll refer an image, and once they refer this image, they can create the container. So let's say you want to create an Ubuntu container. You will take a Docker image that specifies in the creation there should be Ubuntu operating system installed within the container. So once this image is referred while creating a container, the container will have Ubuntu operating system within it. All right. So I hope that clears it out. When you want to create a Docker container, you have a Docker image or you create a Docker image of your own. Like you can pull it from someone else or you can create your own. Now, how would it happen in a software delivery pipeline? So a developer would define the requirements for his software to run inside this image. He may create his own custom image or he may give this requirements to a person whose dedicated job is to create images, right? You can have that kind of job also. So once that image has been created, this image is uploaded to a cloud from which it can be pulled anywhere whenever required. So when the building process is happening, where you're taking the code and the libraries and everything together, in that you would pull the Docker image also onto the particular server or infrastructure where you are building, and there you will run this image so that it becomes a container. So instead of just shipping the container, you are basically sending the image. So because the image is easier to share and collaborate with. So when the tester is testing the software, first he'll pull the image, and once the image has been pulled, he will run this image to run the container. All right. So this is basically how your Docker creates containers. Again, you can think of them like a blueprint architect draws up before anything else for constructing a building. So Docker images are very similar to blueprints. They basically define their definitions of your containers. All right, so what is Kubernetes? Let's dive a little bit more into detail about what Kubernetes is. Kubernetes is an open source container orchestration tool that allows us to manage multiple containers in different types of environment. So it is an open source tool that is basically an open source orchestration tool. It allows you to manage multiple containers in different types of environments. So it's basically what I've told you before. Its role is to basically manage different containers wherever it is required to do so. A big pro about Kubernetes compared to other orchestration tool is that it's very robust and a secure orchestration tool, right? Compared to other orchestration tools. So do you guys know about any other orchestration tools? Well, there are some, like Docker as a company. Even though we've come up with a tool called Docker to create containers, they've also come up with a tool to create to orchestrate those containers also, which kind of makes business point of view, it makes sense, right? If you're creating containers, you want to create a tool that manages those containers also. So they came up with something called Docker Swarm, which is somewhat similar to Kubernetes, but it is not as good as Kubernetes. Even though Docker has mastered the art of creating containers or creating a tool that allows you to create containers, Docker Swarm isn't really up to the mark. Kubernetes is way better in that particular fact. Now, Kubernetes is something that was developed by Google, and after they finished making it, using it all up inside, they basically made it open source for everyone else to use it. So everyone else also got the spoils of what Google had, and then they also started using it, and now Kubernetes has become an industry standard. So you would use Kubernetes in conjunction with Docker many times, and you would be using that in your company. Now, in a lot of times, you will not use Kubernetes directly. You will use Kubernetes based services. So there are a lot of cloud providers like Amazon and Azure that provide you services such as EKS, that is Elastic Kubernetes Service. So that is basically Kubernetes but on cloud, and they've already established everything, they've configured everything. So you just have to go and put in your requirements, and then you can manage your Kubernetes from there. But the core stuff is same. Kubernetes is being used there also, and if you wanted to have it on your own server, then you can do it on your own server also. Not a lot of difference, right? Okay. So it is a very robust and secure tool. So that is a big plus of Kubernetes that people really like about it, is that it's very robust, as in it makes sure that whenever there is a container going down, there is always a backup there, and then it's secure that people are not easily able to penetrate the containers, because containers have very sensitive information. That is the source code of your software. If you don't want to reveal it to the public, or if you don't want to reveal it to any other company, then you want to make sure that it's very secure and that no one can just simply access it, all of it, right? So that doesn't leave us wanting much from Kubernetes. Well, obviously there will be future requirements, but Kubernetes is overall an amazing tool, right? So now let's look at the different features Kubernetes provides us, so that we get a better understanding of what Kubernetes does, at least theoretically. So the first thing that it helps us do is easy updates and easy rollbacks. Easy updates and rollbacks. So whenever you want to update, or pull back an update, then it becomes very easy to do so with the help of Kubernetes. So let's say that you have a certain feature that you want to implement in one of your services. So it's a payment service, and you want to implement a new security patch within that payment service. So it will be very easy to do so, because it's inside of a container, and you can update individual containers with the help of Kubernetes, and you basically put that patch in, and then you're very happy about it. But then after a few days, you get to know that the patch has a very big bug. So you pull that patch back. So when you pull that patch back, that's called a rollback. So you roll back a previous update. So when you roll back that previous update, it goes back to its original composition without having the new security patch, right? So it's very easy to update, and it's very easy to roll back for individual parts of a particular software when you're using Kubernetes. So that is one of the feature. And then storage distribution. Now, storage distribution is also important when you have different services that share particular information. Then you need something called a volume. So in Docker containers, you have something also called volumes, which are not the part of a container. You cannot store data within a container. So that is something that you need to know and understand, that when you create containers and when you put your software in your containers, that is the limit of it. If you want to store large scale data, you will not be able to do it on a container, because then it will reduce the efficiency of that container. So you use something called volumes. Volumes is another object of Docker that allow you to store data without affecting the performance of a container. So you can take a volume and connect it to a container and transfer all the information you want to inside of that volume, and then detach it and then attach it to another container, so that you can transfer the information, or you can have make sure that this particular Kubernetes container has access to a lot of data, and you can have other containers also having a lot of access to a certain volume. So it becomes very easy to share and store data over there. Secret handling. Now, secret handling is also a very important aspect of Kubernetes, because you'll be managing and looking at different kinds of secrets when you're working with software. When you're discussing about handling sensitive information, Kubernetes shows its boasting hand, where it tells you that it can very easily manage secrets, and there is a best practice to be followed. When you're talking about secrets, you never store them within a container. You use orchestration tools for this purpose, because if you're storing it within the container, it becomes very vulnerable. It becomes a security vulnerability. If somebody is able to access that container, they'll be able to take that information and use it against you. So there are things like SSH keys, your passwords, your authorizations, so tokens, and all of those different things. So you have a secret handling feature of Kubernetes that allows you to easily and safely manage all of the different sensitive informations, or secrets. Then you have heals itself. Now, heals itself is also a very important feature. So when I talk about heals itself, imagine a cluster of different containers. And in this cluster of containers, you have your software, 5 containers, and inside of this, you have 5 services. Let's say that one of the services, that is let's take that example of the payment service again. And that payment service, right? So imagine that you put in the new patch and it makes it vulnerable, and it makes it not vulnerable, it makes it crash. So the payment feature crashes and the whole container crashes because of that. So when it crashes, what you do is, instead of having that container up, that specific container up, you have a backup ready that goes in its place. So that is called self-healing. So a Kubernetes will make sure that if any container is on the verge, or if it crashes, then there is a backup, and that it heals itself, that it brings something to make sure that the product is functioning as well as possible. That's why it keeps replicas of its pods. And we will discuss what pods are and what replicas are more into detail later. And load balancing. Now, load balancing is also important. You need to manage the kind of traffic that is going from one particular service to another. So you need to manage how much capacity there is. So Kubernetes is also very good at doing that. And again, easy scaling. So scaling is an important matter when you're working in a big company, and when you're working with a software that has millions of users that vary from time to time. What do? Do you set up like a million servers and then just spend that much money, even though at one point of the day you don't have million customers, you only have like 100,000 customers? You're losing money over there. So scaling is like a cost effective method. It means that you remove certain extra servers when there is no need for it. And there is auto scaling, where where it automatically detects how much traffic is coming in, and accordingly it keeps that set amount of servers. If more people are coming, it scales it. Once it scales it, more people can come in. And again, scaling plays into matter of fact, where you have more services to add. Let's say that you have more services to add to your software, like instead of the payment and other features, you want to add a new social platform or a video platform, streaming service within your food delivery app. So you can do that also with the help of Kubernetes, where you introduce more particular services, and that is scaling your business, right? So it allows for easy scaling of any kind of operation over here. So Kubernetes has a lot of different features that really help it to manage our software. And that's why Kubernetes is amazing. So how does Kubernetes really function? So let us go ahead and understand how does it do what it does. We know what it does, but we do not know how does it do it. So let us look at the collection of nodes. So when I say nodes over here, I'm trying to say servers. So individual servers will be called individual nodes. So you will get to know why do we call them such, and what is the implication of this. So there is always a manager node and there are always worker nodes. So on your manager node, you'll have the manager components, and this manager node will be, managing all your worker nodes. All right, and all of it will be called a cluster. Now, in each of your worker node, you will have something called a pod. So this pod is basically something that your Kubernetes is handling, and inside of a pod, you'll have multiple containers. So whenever you're working with Kubernetes, each Kubernetes will be basically handling different pods of containers, and each pod will have multiple containers. So now we know that inside of a worker node, you can have a pod. Now, a pod is basically a logical set of containers that may be required for a specific application. So if you have a food delivery app, and inside of that app, you have different parts, each part would need its own pod. So if there is a payment feature, then the payment feature will have its own pod. Now, there may be one or there may be multiple containers within a pod. That is based on a requirement. And if you have multiple containers, that means you are doing an advanced use case, right? So taking that example in mind where you have different features and each feature will be represented by a singular pod, right? So we know now what a pod is. So now let's look at the Kubernetes node cluster where you have one manager node that manages all the worker nodes. And then inside of each of these worker nodes, you have multiple pods, right? And each pod is representing a feature. Keep that in mind. And I want you guys to differentiate the word service from feature, because I use service a lot in my previous examples, but I don't want you to get confused when it comes to talking about the Kubernetes components, because service in a Kubernetes architecture is totally different than what we were talking about earlier. So totally erase that part from your mind, and we'll be discussing a new word service is. For now, understand this is what a Kubernetes node cluster would look like, where you have one manager node that is managing several worker nodes, and in which you will have multiple pods. We'll see an in detail breakdown of this when we go a little further. For now, let us understand the Kubernetes components. So there is something called a service. So let's say that you have 3 pods, and these 3 pods basically do what you want your application to do. So you have everything you need. You have 3 pods, and these 3 pods basically allow you to basically pay for something. But how does the customer actually access these pods? Does he have to go directly access the IP address of the pod, or what? Because even that is actually not something you would allow, and it's not a part of a best practice. It's not even safe. So instead of having the customer directly go to the pod, you have something called a service. Now, within Kubernetes, service is something that represents a logical set of pods. So if you have your payment feature, and that payment feature compromises of 3 pods, then that particular, set of 3 pods will be accessible through a service. Now, even within a service, there are different types of services, and these services may not always be accessible to the external URL, or it may not be accessible to the customer outside. There's only actually one kind of service, that is where it is possible. But even in that case, you don't expose your service externally. So within Kubernetes, you will have multiple services that will represent different parts of your application or part of your software. And these services will be connected by another thing called an ingress. Now, an ingress is used to make an external access of an application. So if you want to have an external URL through which your customers can come and access your application, then you make use of an ingress. So you'll have one ingress, and within one ingress, you'll have multiple services that will have multiple different roles. And within those services, you will have different pods. So let me visualize it for you. You'll have one ingress. you'll have multiple services here. So for one, service 1, service 2, and service 3, and within those services you'll have multiple pods that represent each of the services. So each service represents a logical set of pods that totally is like a gateway, and the ingress is basically used to give external access to the whole application to the user, right? So this is the whole cluster architecture. Now let's look at the Kubernetes cluster. Again, it is the manager and node thing. We are just going to dive a little deeper into it and understand what are the different working parts of it. So over here, you can see that there are many different parts inside of the manager, and there's something called kubectl also. I'll tell you what all of these things do. Let me just show you what are the other parts that are there. So there's something called etcd also, which is plays an important part in this whole architecture of Kubernetes. And then you have the worker node also. Now I've only shown one worker node over here, but you can have multiple worker nodes, and within worker nodes you have things like kubelet, kubeproxy. You have different pods, and within these pods will be created using some kind of container creation platform like Docker. If you're not using Docker, you can use some other container creation platform, and this worker node will be connected to the manager node through the help of the API server, and there'll be a connection to the external host from the kubeproxy also. So this is basically what your Kubernetes architecture would look like, right? So this is something we saw earlier, where we saw the manager node and worker node, where we just saw the front facing of it. We didn't see anything inside of it. Now we're looking at the inside of it. So this is what the client slave architecture looks like. Now let's go through all of these things one by one. So there's something called kubectl. Now kubectl is basically Kubernetes' command line interface. It's something that you use to give commands to Kubernetes to basically do whatever you want, whatever perform operations you want to perform. You would do so using the help of kubectl. And inside of manager you have three main important things. First is the API server. Now API server is basically the one that is responsible for communicating any operation that we want Kubernetes to do, and it will basically communicate those responsibilities or those requirements to whoever it needs to be communicated to. Now you can always increase the number of API servers that you have if you want to basically expand your basically the amount of traffic that you want to take in. And if you just want to increase the number of API servers, there is an option for you to do that. And it serves the big purpose of dividing the workload between a lot of the other servers. Now there is another important thing called etcd. Now etcd is very important because it has a lot of different information. So it has things like sensitive information. It keeps sensitive information, and if any part of this particular worker node, any container wants to access the pod, wants to access any sensitive information, then it has to do so by asking for it from etcd. And it also has a lot of different information, like things that are required. It has a lot of different config files. It has things that are required to run Kubernetes itself. To run Kubernetes, where's the knowledge coming from? The knowledge is stored in etcd for that purpose, and a lot of different configuration files are also stored in etcd. Now it is not strictly a part of manager node, but it is a part of your Kubernetes cluster architecture, right? So that is etcd. Now let's talk about the control manager. Now control manager is basically used to control all the different controllers there are. You have node controller, you have service and account token controllers, you have endpoint controller, and you have replica controller. Now node controller is basically something that is responsible for managing and taking care of the nodes. If a node goes down, then it makes sure that the node comes back up. Replica controller is responsible for making sure that the replicas are available and can be used if you want to increase the number of them. And then service account and token controllers are basically used for making sure that the tokens are available for the purpose. and endpoint controllers that basically allow or make sure that all the different pods have different endpoints, and they're able all the different services are able to talk to each other using those different endpoints. So it's responsible for that. Then there is something called a scheduler inside of the manager node. Now the scheduler basically helps in scheduling all the different processes, and it also helps in basically load balancing between the issue the requests that are coming in. So that is basically our manager node. Now let's move on to talk about the worker node. So in worker node, we have a lot of different things also, where we have Docker, where we have kubelet, we have kubeproxy, and inside Docker we have different pods. Now we already know what pods are. Pods are basically a logical set of containers that form an application, and these pods are created by Kubernetes, but Kubernetes takes the help of a container creation platform like Docker. In this case we are using Docker, but if you wanted to use some other container creation platform, you could go ahead and make use of it. But here we have mentioned Docker because Docker is the most popular one, and Docker is the one that I know also. So there are other things also. You have things like proxy, kubeproxy. Now kubeproxy is basically a service that runs on every worker node. So as I said, there is not just one worker node. Just for the sake of clarity, I have included only one worker node over here. So but there will be other worker nodes also, where you will have kubeproxy running on each of them. Now what this kubeproxy basically does is that it gives these particular worker it gives access of the services to the hosts that are there on which these worker nodes are on. And basically it does a little bit of load balancing from here and there. It does some extra other tasks also, like making sure that any new pod that is coming up is healthy or not. It also helps in managing secrets and different volumes there might be, but its main purpose is to serve as a proxy, where it allows external host access to the pods, right? So that is your kubeproxy. Then we have kubelet service. Now kubelet service basically tries to make sure that information is being received and being sent from the control panel, or basically your manager, right? So if a manager has some request that is being coming from kubectl, that is coming from the user, so that request has to be given somehow to the workers, to the pods. Like if you want to update a particular product or a particular project or app, you will send that request, and it will go to the kubelet, and from there it's basically going to apply the changes whatever there are. So basically kubelet is responsible for managing all the pods. So these are the different parts within your manager node as well as your worker node. So I hope you guys understood what they were. Right, so now that we've understood all the different components, the whole cluster and the architecture within that cluster, we can move on to discuss what Kubernetes is and how we can go ahead and install it and set it up. So it is a little bit of a difficult process, and we will be doing this using Ubuntu Linux, right? So to use Kubernetes, we need a bit of power also. So what we are going to do is basically we are going to launch an Ubuntu Linux server using AWS. AWS is a cloud service, and what we're basically going to be doing is we're going to rent a server for free, and on that server we're going to be running our Ubuntu Linux. It makes it very easy, and it gives you a little bit of practice in real life also, because these days not everyone won't have on-premise servers where they will install Kubernetes. But they'll be using cloud services like Azure and AWS. So I'm just going to scroll down and choose the AMI I want. Now I'm not going to go into a lot of detail on how to choose the AMI that you need to and what to do once you do it, how to configure it. But I wanted to show you one thing over here. That is the requirement. Now we're using EC2 service. Within EC2 service, we've chosen Ubuntu as our operating system, as our AMI, and we are going to be using T2.medium as the type of instance we're using, because Kubernetes requires a lot of power and we need at least 4 GBs of RAM, right? So that's what I'm going to be doing over here. We have 2 CPUs and 4 GB. So I'm going to go ahead and click on configure, and I'm going to launch 2 instances, because we are going to be setting up a master slave architecture over here. So we need one manager and one worker node. So remember, these nodes are basically your servers that we are starting. So let me just go ahead and create a new security group. all traffic, anywhere, review and launch. I'm going to choose my keys, acknowledge, and then launch instances. Right, so we are basically launching these instances. It takes a few seconds to launch them. Once they're launched, what I'm going to do is I'm going to connect to them using as a SSH client. But before that, let me go ahead and name these. So I'm going to name this one worker, and I'm going to name this one manager. So you guys can see what we're going to do. We're going to emulate our master slave architecture that we just saw in theory. All right, so I have my master over here. So I'm just going to open my SSH client. Now, instead of opening an SSH client, you can just use any terminal to access it by using an SSH command. But it's easy for me to use an SSH client, so that's what I'm doing. So I've loaded up my settings. I'm gonna copy my IP address and I'm gonna paste the IP address so that we can access it. All right, so we're just gonna wait for the instance to finish loading up and then we'll open it up. All right, so it's done loading up and we can open it. All right, so I'm gonna click over here, yes, and I'm gonna log in as a Ubuntu user. Great. So now we have basically logged into our Ubuntu server. So that is great. We can do anything that we could do on normal Ubuntu over here also, because this is Ubuntu server basically, right? So what are the steps for installing Ubuntu? So there are quite a few steps. So let me take you through all of those steps. So the first thing we need to do is we need to update our apt package manager, right? So what I'm going to do is I'm going to do sudo apt update. So this will basically update the Ubuntu's package manager, that is apt, so that we don't have any issues. We have the latest information. And once this gets updated, we can move on to the next step, that is to install Docker. Now again, the platform we are using for container creation is Docker. Let me show you the steps. Sudo. Now you can use apt-get or you can just use apt, right? So I'm going to go ahead and press enter, and this will install Docker for me. Now, if you were setting up a proper environment for Kubernetes, this is not how you would do it, because this Docker version may not be the latest version. And this is because the package manager has a certain address where it goes to download Docker and install it, and that address may not be updated. Almost like a lot of times it's not updated to be the latest version. So to get the latest version, you need to go to Docker's own website, and in the documentation they give the correct address for the latest version. You can just copy that using wget and install it after you get your keys. So now that I've installed Docker, I'm just going to check if Docker is properly installed or not. So I'm going to do docker-versions. Docker is installed. We can move on to the next step, that is to start Docker. So let me just go ahead and paste this command. So this command is basically sudo systemctl start docker. So this should start up Docker. Right, so now we're going to do the next step, that is to install a certain set of packages. Actually, one package, that is our apt transport HTTPS. This is for transferring stuff over the HTTPS protocol. All right, gives us an error. This is because we did not give it root access, right? And we don't need apt-get, but you can still use that. I'm going to press enter. It will start downloading the apt transport HTTPS package. All right, it still says access denied. So let's get root user access. And I'm just going to copy this again, and I'm going to paste this. So the command is apt-get update and then apt-get install. -y basically means yes. If it asks yes or no, then I'm going to press enter. So we just needed extra root access. So we're just going to leave it at super user access over here, so that we don't get any of these issues again. Now I'm going to come back over here, and we're going to do the next command, that is curl-s https //packages. Let me just copy this, come back, paste it over here. Right, so these packages are so what we're basically doing is we're going to go ahead and get the key, so that when we download Kubernetes, we can use this key to access it, right? So while we're downloading it, not while we're downloading it, to download it, right? So we added the key to apt. Now apt key has that particular key in it, so it says okay, this is what you should be getting also. If you don't get it, then look at the command again and copy correctly, come back, scroll. So over here, then we'll use the next command, that is apt add repository. So now what we're doing is basically we're pasting the address into apt package manager where Kubernetes is. So this is the address where we're going to get Kubernetes, and we're going to be adding it to apt package manager. If I press enter, you can see that it has updated apt to now have Kubernetes also with it. Great. So now we can go ahead and directly install Kubernetes. So to install Kubernetes, what we're going to do is we're going to install kube admin and kubelet and kubectl. So let me just go ahead. I already explained to you what these things are, and press enter. All right, now that we installed all of those different things, we can go ahead and check if the kube admin is installed or not using this particular command. All right, so this means that our kube admin is installed, and we can go ahead and do all the other processes. All right, so our next step is going to be initializing a cluster, a Kubernetes cluster. To do that, I'm going to go ahead and use this command. Now I will explain to you this command, or what we can do is we can just type in kube admin init, right? And press enter. So you can see that it has started the process. Now this is a big process. It is using Kubernetes version 1.2.20.2. It's running all the pre-flight checks over here. In pre-flight checks, it does a lot of different checkings, like it checks if Docker is there or not. I don't know why it's saying Docker service is not enabled, because we specifically had a command to enable our Docker. Now it will do all the other pre-flight checks, and it will start use the it is creating the admin.conf file, kubelet.conf file, controllermanager.conf file, scheduler.conf file over here. It's writing Kubernetes configurations, and basically it has started it up. Now it's telling us your Kubernetes control panel has initialized successfully. To start using Kubernetes cluster, you need to run the following as a regular user. So these are the commands that we should be running as a regular user. So let me go ahead and copy these commands, and what we will do is I am going to basically run this as a shell script, because I'm a little bit lazy in typing all of these commands one by one. So what a shell script is, it basically is a script where you can type in all the commands that you want to and run it in one go using the sh command. So it will run all of these commands. So we ran all of these commands. All right. So next thing that it tells you is you should now deploy a pod network to the cluster. But before we go ahead and do this, what we really want to do is we need to attach our worker nodes, right? So before I actually deploy, I want to go ahead and install Kubernetes on my worker node, and I want to use this particular command to make my worker node join my Kubernetes cluster. So let's go ahead and actually open up our worker node. So we have to do the same thing over here. I'm going to come back and select the worker node, and I'm going to open it using an SSH client. So the SSH client here I'm using is PuTTY, but if you guys want, you can go ahead and directly use the SSH command itself in any terminal. Yes, and I'm going to log in as Ubuntu. Now to distinguish this from others, I'm going to go ahead and change its color a little bit. Modify, we'll make it cyan, right? So now it's a bit different. Now it looks like a worker, right? Okay, so we're going to go ahead and switch to root user access, and I'm going to go ahead and type in all the commands that we wanted to use to install Kubernetes. So apt update. So this will update it, then we'll install Docker on this. apt install docker.io-y. So this is the command to install Docker. Now remember, if you are not accessing this as a root user, you need to add sudo prefix to any command over here, right? Since I already am a super user, I do not need to do that. Now generally it's a better practice to not be a root user to do all of these things. You should be using the prefix sudo, but just for the sake of practice, we are doing this. All right, so now that we've installed Docker, let me just make sure the installation is fine. All right, the installation is fine. And now I'm going to go ahead and install the apt https package, that is Yeah, so that is the apt transport HTTPS curl package. So let me just install that. It's gonna start installing it. Now that we're done with that, we're gonna again get the key. So I have to get the key and add the key. I got the OK, that is great. Now I'm gonna go ahead and add the address for Kubernetes into my apt package repository. Package manager, sorry. Yeah, I'm gonna come back and I'm gonna install kubeadmin, kubelet, and kubectl. Right, so we've installed Kubernetes over here also. Now we just need to type in a kubeadmin command to see if it's installed or not. Sorry, we don't need the hyphen hyphen. Right, so we have Kubernetes installed. Now our next step is to basically make this worker node join our Kubernetes cluster. So we do have a cluster over here. Now to join this cluster, that's what it says. Then you can join any worker nodes by running the following command. So it gives you the command. So you can just copy the command and go ahead and paste it in your worker node. So you can have more than one worker node. You can have 2-3 worker nodes. I decided to have only one worker node. So this error is coming up because of a very specific issue that I missed out. So whenever you're using kubeadmin to create, a cluster, what you really need to do is you need to use this command. That is kubeadmin init pod, and then you need to add this flag that is hyphen hyphen pod hyphen network hyphen ccidr equals to 10.244. So this is basically a virtual network that the pods will use, and if you don't do it, this is the error you get. So that's why I have reset it. And if you guys were following me, what you guys can also do is you just type in adm and just type in reset, and it will reset your cluster so that you can start the whole process again. Now that since I've already done that, I can take in the new command and right, so I'll take in the new command. Let me just copy this properly, come back over here, paste the new command, and then press enter. So you guys can see that it's running the pre-flight checks again. All right, so now we have another working node on our cluster. So if I come back over here and if I do a kubectl get nodes and press enter, so you will get this error because we did not do that initialization again. So let me just copy these commands and play them. I mean, enter them. Copy this command, paste it. .sh, right? Let me just execute it. We already have that file. So if I execute it, yes, I want to, yes. All right, so it's done. Now let me use the command kubectl get nodes. And you can see that I have 2 nodes over here, right? So both of these nodes are there. This one is not ready. That's fine. And we have the 2 basically nodes. If I just cross-reference using the IP address, I can see that the IP addresses are correct. This is 2219, this is 2219, and this is 29225, and this is 29225. Great. Now I've basically launched my Kubernetes cluster where I have a master slave architecture, right? So this is great. We've installed it and we have set up a Kubernetes cluster also. Now, let's move on to the next part of this. Okay, now let us talk about YAML files. Now, the full form of YAML is YAML ain't markup language, right? So YAML is a superset of JSON, and whenever you want to use YAML files, you're using it for the purpose of configuration. Now, you use YAML files in a lot of different places. If you use Docker before, then you know that you have to use YAML when you're working with Docker Compose. Docker Compose. There you create a Docker Compose.yaml file, and generally whenever you're using a YAML format, you have to understand that you are creating a configuration. Now, configurations are generally set of settings that allow you to define how a particular machine is going to run, or how a program or a software is going to run. If you create a .conf file, that is for setting different kind of configurations, but let's keep that aside and now understand how we can go ahead and write a YAML file. Right. So to write a YAML file, you need to understand there are two different types of structures. The first structure is maps, right? So the maps structure is basically your key value pairs, where you write a specific key and you give a value to it. So if you're using kind as a key, you have to put in, deployment or volumes or service or ingress, whatever thing object you're creating from in Kubernetes. Or if you are using, the specific Docker image, you have to mention the name of the Docker image you're using, and you have to mention key as image, and then you have to mention in value the Docker image, or in the starting itself what kind of API you're using. If you're using apps/version1 as the API, then the keys will be the API and the value will be the basically whatever API you're using. So it is defining what specific things you're using. It is setting the settings, right? So that's what maps is. Right? Okay, now let's move on and discuss lists. So lists is somewhat similar, but it is different in the matter of fact that you have one argument, and within that argument you have multiple lists. So if you wanted to give certain values for a specific thing, like for example, if you're setting up a deployment in which you are setting up a specific Docker image, right? And you wanted to specify different settings or different things about the Docker image, then you'll have to mention the argument, and then within the argument you have to mention what is the container port at which is open, what is the name of the Docker image, what is the name of the whole thing. So that's how you come up with list. So we will go through both of these things when we're actually going through a .yaml configuration file. So where do we use YAML files in Kubernetes? So in Kubernetes, you're using the YAML files to basically, make all the configuration changes. So let's say you have an API and you want to make any configuration changes, you will basically open up the YAML file and make those changes. Or if you want to do that in a scheduler, you would go ahead and open up the scheduler's YAML, the configuration file, right? So that's where you use YAML files, and you use YAML files in Kubernetes to create all the Kubernetes objects. Like if you wanted to create a service, or if you wanted to create a set of different pods, or if you wanted to create the ingress, right? That's where you would use the YAML file. Now, why do we use YAML file in Kubernetes in the first place at all? So there are several reasons. So the big thing about YAML is that it's very expressive and it's very easy to read. Even you, as someone who's not a lot of idea about Kubernetes and the configurations that you have to set in Kubernetes, you can always read through the configuration.yaml file for any deployment or anything and understand what is going on, right? We will see that when we actually look at a YAML file. It is very easily basically readable by humans. And it is very easy to use also. If you want to make any changes, you have keys and then you have to just adjust the values for it. Instead of having 3 replicas, you can have 5 or 6 replicas. So you just have to go to the .yaml file and make that change that you want to. Another great thing about YAML files is that it's very easily portable between different kinds of programming languages. So it increases your migration abilities also. And YAML files have a very, very, generic structure, or more like a more consistent structure, so that it can be used in different kinds of places. And when it gets communicated through the API, it gets converted into JSON also many times. It basically gives you a lot of flexibility. You can create very, very complex things while using YAML, right? It can be very, configuration YAML file can be very long, and it can be very easy to make. Now, there are some hiccups when you think about creating YAML files. And one of the most important ones is knowing when to add a space and knowing which value to enter, right? Because you need to know what to change. If you don't know what to change, what will you change, right? So let me open or show you guys a YAML. Over here in my notepad, I have a YAML file. and you guys can see this is my YAML file for launching a particular set of pods, two pods on the Kubernetes cluster that we have launched. And let's understand this one by one. Now, as you guys had seen, there are two structures. There's the mapping structure where you have one key and you have one value for it. So for API version, you have app/v1, you have for kind, you have deployment as the value, and then you also have lists also. Within containers, which is an argument, you have many different, arguments here. Like you have name, you have images, you have ports, and you have container port at which it is open and all those things. So this is how it follows that particular structure. Right now, let us go through all of these different key value pairs one by one. So we have API version, which basically dictates what kind of API you want to use for what object, right? So app/1 is a specific API that allows you to create deployments. So in API version, you have to make sure that whatever API you're using has that specific kind also. So here with apps1, we have deployment in our kind, and for the deployment, we have specified some metadata. And within the metadata, you can see there are different lists of things. You have names and labels. So the name is Apache Web Server. Now the name is Apache Web Server over here because we are going to be launching Apache Web Server, or on our cluster. So you can call HTTPD also. In the name of the image is HTTPD. So that's why we mentioned that, and that's why we mentioned the name over here. So this is basically metadata. It really doesn't affect a lot of different things. But there is something important even within metadata, that is labels. So in labels, I mentioned role, and with role, we mentioned Apache server as the role. Why have we mentioned this? Because we want to make sure that this comes under the name of Apache web server, and we can basically match these labels. So when we specify how many replicas we want to use, right? Let's say we want to use 2 replicas. That's what we mentioned for replicas over here. We've matched with the label over here, that is Apache server. And similarly, even in the template, we match the role as Apache server. So if we had different roles, then we could, basically assign different roles and match them with different roles. All right. So now if we come down and we talk about the image that is being used, that is the part where Docker comes in, right? So for containers, we mentioned the name of the container is going to be my app, and the image that we're going to pull is HTTPD. So what will happen is, it will look for the HTTP image online, and since it will actually look for this image locally. So if you have this image locally, the image will be referenced very fast and the containers will be created very fast. But since it is not there, because I know in my server I have not installed Apache web server image or downloaded it, it will basically look for the image online, and once it finds it online, wherever the address is, it will pull it locally. And once it pulls it locally, it will refer this image. It will use Docker for the purpose of referring the image and then creating a container out of this image. Since we've mentioned the image to be HTTPD, then the container that Docker will create, the 2 containers that Docker will create, are basically your HTTPD containers that have Apache web server downloaded and installed in them. And we also mentioned the port at which the container ports are exposed. So 80 is the default port. That means if the container has a specific IP, then it is open at the default port. If you just mention the IP, you're able to access it. So this is basically how you would go ahead and define a particular YAML file to create a deployment. So let us actually use this, right? Let's try to deploy this. So let me bring up my manager node over here, and let's go ahead and open up an editor. And inside of this editor, I'm gonna name this fun.yaml. Yeah. So over here, I'm gonna go ahead and take all of these configuration settings and paste them. So as you can see, it is very clearly visible what is what, and it's very readable and understandable because it's just key value pairs and lists. So it's very easy for us to read, and it is very simple to use also. Now, since we have pasted our particular key value pairs over here in our fun.yaml, we can go ahead and apply this configuration using a certain command. So let me go ahead and save this, Control O, enter, Control X. So we have a fun.yaml over here. Great. So we can go ahead and apply this. But before that, I just wanted to tell you guys where when you're writing in YAML file, it's better always to do it in some kind of editor. So if you work with Visual Studio Code to, write any of your code, or if you're using IntelliJ, or if you're using Eclipse, or whatever, code editor you're using, even if it's Notepad, it's better to use a code editor to write a YAML file, because even a small indentation error, right? Indentation would be the space you have over here. Even if there's a small indentation error, it will not run properly. So that is one hiccup about YAML files, where you need to have very, very specific indentation and no unnecessary indentation, right? So you have to keep that in mind. So never write it within a terminal using a editor on a terminal itself, right? It's easy to do that, but I would not recommend for you to do this. Or you can, if you're brave enough, you can always go ahead and do this and try this out. So, right. So let me just go ahead and apply this. So first I will see if I have my nodes or not. kubectl get nodes. We have our nodes. Okay. Now what we're going to do is kubectl apply -f, and I'm going to mention the name of my deployment, that is fun.yaml, and then I'm going to press enter. So we got an error, that is, it's telling us that my app, a lowercase label must be considered lowercase alphanumeric. All right, so let us go ahead and make this change. So I'm just going to open up my fun.yaml, and we're going to go ahead and change the name of my app over here. Save this, Control O, Control X, and let us try and apply this again. All right, so it has created our deployment. So you can use kubectl create -f also, but I've used apply, and it has created our deployment. Now to see whether our pods have been created or not, we can use the command kubectl get pods on the manager. Okay, so once you type in that command, it will show you the name, the ready status, whether it's ready or not, the status, the restarts, and the age. So it just started 21 seconds ago, and it's showing that it's still pending and it's still in the ready state. So if we keep on checking it on regular intervals, we will see that the status has changed a little bit. Let us wait for a few more seconds, and we can see that the status will change. If it's still not showing up for you, then there is a chance that your network plugin has not been added by default, right? So if this still does not come, please try and go ahead and apply this particular command. What you can do is you can basically take this command kubectl apply -f, copy it and paste it. So it's a network plugin that we should have done actually earlier. Now that we have applied the network plugin, let's try this again. kubectl get pods. So it will still take a few seconds. If it still does not, I would recommend installing it again. And this time, putting this command before you start the pods. So to avoid any confusion, what I will do is I will put this text file up in the right order so that you guys can install it properly. So you guys can refer to this installation and use it to install so that you don't face this error. But as we can see, the container is being created and it's running, and we have both the pods up. So which is good for us because both our pods are running, and you can go ahead and get a description. You can get a more brief information about all of these pods, where they are running and everything. And there is something interesting. You can run Docker commands also over here. So if I did a sudo docker ps, you guys can see all the different containers that are running over here. And they all serve different purposes for Kubernetes to run also. And same with our worker node also, sudo docker ps. Yeah. So if you wanted to use Docker side of tools, and if we do kubectl get pods hyphen all namespaces, you guys can see where all the different pods are occupying the namespaces. Now these are the two ones that we've launched, and then you have a lot of them that are running by default, right? So it gives you the ready status and all of that. And you can get a description also. So if we type in the command kubectl describe pods, you will get a description of all the pods. If we scroll a little bit more up, this is where we typed in the command, and you guys can see for each pod it gives you the name. So for Apache web server, this particular pod, it gives you the namespace. So the namespace is default. There is no specific priority. It tells you what node is it on, what virtual your private IP it's using, and what time was started, what are the labels for it. So you can see role equal to Apache server. It is added as metadata for it. And you have annotations, the status of it, whether it's running or not, the IP address of this particular pod, and who is it controlled by. And then again, containers, you can see the name of my container, the container ID that is being used. So this is the container ID, the image name, and the image ID that is being used, the port at which it is open. It's open at the port 80 using the protocol TCP. The host port that is open, it's not open at any host port, so that's fine. And the state is running for this also. And if we scroll down, you can see a lot more different things that if we go into detail, we can have a whole another session just talking about these details, right? So if you come down, you can even see the events where it sees the warning where it failed scheduling. So this probably happened in the starting when it wasn't running, and then you can see it normal, and then it's scheduled, and then it starts talking about the other apps, right? And then it was finally created. So if you come down, it tells you about both of them, both of the pods that we created. Now we can go ahead and try and do this kubectl describe nodes also. So this will give us information about the nodes that we are running. So we have one manager node and one worker node, and you can similarly see a lot of information coming in. So if you keep on scrolling up, you can see there's a lot of data. So this is where we typed in the command. It gives you the name, it gives you the IP, whether there are any roles, what labels there are, the annotations that we use, the creation timestamps, the lease and holder identity, conditions, then what are the things that happen, events, address, capacity. It has 2 CPUs, and how many pods allocatable. It has allocatable 110 pods. That's what it means by that. And if we keep on scrolling down, it shows you system information. So this is basically the system information, the OS image. We're using Ubuntu, and we're using container runtime version. So this is the container runtime architecture. So we're using Docker for this purpose. If you had used maybe Rocket or LXD, then it would show that particular version over here, and show the proxy version and kubelet version also over here. All right. So this is how you get the information for it, and gives you information for both the nodes that you have in your cluster. Now you can do this for n number of nodes that you have, but that isn't really intuitive, as to say. So Kubernetes is something that you can launch on your local systems, and you can set it up for local purposes also, but is generally used for deployment. Now deployment is, as I had explained earlier, you're giving the product to the end users, and to give it to the end users, you have to make sure that your service is running, and you have to create service and ingress for that also. So maybe in another session and tutorial, we can explain how to create that, as that is a little bit more complicated process and out of the scope of today's tutorial. So to guys reiterate what all things we learned in this particular tutorial was, we learned what Kubernetes did to resolve an issue we had. We learned that software development is a process, it's a complicated process, and even in a simple pipeline, you can have bottlenecking issues that needed to be resolved. So we resolved it using containers, right? And when you had multiple containers, you can have your software divided into multiple parts and implement a microservices type of architecture. And when you want to manage and maintain such an architecture or such a deployment, you need to make use of an orchestration tool, because containers can be easily managed with the help of orchestration tools. And hence we use Kubernetes. Kubernetes is an orchestration tool that allows us to manage the multiple containers that we're launching, right? So we learned what Kubernetes is, and then we talked about what are the different features of Kubernetes, how does it how it heals itself, how it's, you're able to easily scale, and how you're easily able to update and do rollbacks. And then we talked about the cluster of Kubernetes, where you have one manager node. It's a master slave architecture where you have one master and multiple slaves, or one manager and multiple workers, and in each worker you have multiple pods or a single pod, it depends. And in each pod you can have either one container or multiple containers, right? And then we'll also learn how the whole flow is, where you have one ingress, you have multiple services, and within multiple services you have multiple pods. So that is the networking part of it. And then you have we dived a little bit deeper into talking about the whole architecture, where we discussed what is inside a manager node, the API server, the scheduler, the control manager. Then we talked about the etcd, how it is important for storing certain information that is required for Kubernetes to run. We talked about what is inside a worker node, the kubelet, the kube proxy, and the Docker, container creation, container runtime creation platform, and then you had pods inside of it. Then we learned how to install Kubernetes, where you have a multifaceted steps, right? And don't worry, guys, I will include the steps for installation of Kubernetes, the proper steps, in the description, so you guys can go ahead and access it. And we also learn how to basically use YAML files to put up deployments. We learn what a YAML file is and how it helps us to launch deployments or put deployments on clusters, right? And we did that for Apache HTTPD server. So that's what we learned in this tutorial. So I hope you guys take this knowledge that you've learned about Kubernetes and use it further. Keep on doing your personal projects. If you have any, a particular website that you want to create, then create that website and deploy it using Kubernetes and Jenkins and Docker and everything. That way, the more you practice, the more you learn. So that is all I will tell you for now. And I will leave you with this thought that, software development is a very complicated process, but we have a lot of methodologies and tools to help us, make it easier. Thank you so much for watching, guys. I really enjoyed teaching you, and I really enjoyed, talking about all the different things in Kubernetes.
And again, guys, Great Learning Academy. It's a free initiative by Great Learning where you can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. And if you haven't subscribed to our channel yet, I want to request you to hit that subscribe button and turn on the notifications bell so that you don't miss out on any new updates or videos released from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any queries or suggestions, and I will respond to your comments. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out on any new updates or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. And make sure to comment on the video for any queries or suggestions, and I will respond to them.